ChatGPT saved my ass with Jacobian matrix because the proof was not understandable until I kept on asking ChatGPT on how the hell do I do this. So I finally figured it out, and I realized I need to do surface integrals and line integrals before I do this part, which means I'm gonna do a little bit here in part two and part one. I'm gonna do split into two because it might be easier that way. Before I go to the Jacobian matrix, because there's two proofs I did. One of them is a proof I learned in class because it's actually maybe I learned the other way too, but it was an online class, so no one was really listening to a half online, half hybrid, so no one was really listening to properly. So that year was weird. It was yeah, it was 20 when they talk about it. So anyway, or maybe I just didn't understand it because I did listen to all the lectures. It just didn't click at that point, or maybe I don't know. But I don't remember learning this shenanigans, so maybe not. I think we did learn it this way because either way. I was doing other things in this. I will explain this entire proof. It's just gonna be a pain in the ass as usual. Um, there's a few things I want to talk about before we get in there. Um, first I changed up all of the geometric proofs because I realized a lot of these things came from different what's or cultures. And you might think you shouldn't care about that, but then why do we care about Newton's law and the Newton we always call Newton? So I just thought, well, I'll put that in there, like it was actually discovered by Bayle in Egypt and things like that, because I don't really no one really knows who actually created it, but it was somewhere in Egypt. And then I don't really know much about these people, but I'm just gonna put a bunch of other people that I think helped in discovering this or made it. I don't know which one. Once I figure out which one actually made the modern sine, cosine, tan to its reality, I will obviously choose that. I think it's probably some Indian guy or a Middle Eastern person because I know a lot of sine. If I go over here, um, as oh my god, I forgot I did all the shenanigans. Is one of these people. I will have to figure out which one. Is why I put these two, but I'm pretty sure they're not. Is because they haven't did the modern one. They did some kind of flimsy one, um, that really wasn't the modern concrete one. I think it's Al Cascio for this one and Al Belni, but I have to double check. It would be something I have to double check continuously, and I haven't really had time for it. There's another one with simplifying polynomials. I think it's part two, where the quark from it's one of these people. I don't know which one created the final version, but it's one of these three that created it. Uh, so I'm just gonna figure that out as I go later on. I really don't know who it is. Well, I might not even update that. I might leave it like that and just say, yeah, you can search it up and figure it out. I don't know. I should probably not do that. But anyways, yes. Oh yeah, and I really need to put more of those characters because I know a lot of these are not created by. This is created by Euler or something, but a lot of these are not created by him. It's created by someone else, especially the determinant other stuff. And yeah, the reason I'm saying it is because a lot of the names, a famous equation we use, the names, we don't really memorize it because I'm thinking it's because it's the very complicated names that the person that made it had, and the names that they had, no one wants to say it. In my personal opinion, that's probably it, because their names is like very long, some of them. So I'm probably only put the last names in because good golly, that's it's like this long, and I just like it'll just clog up everywhere. But I do want to give them credit and respect on their name because you should always. I mean, I personally believe a lot of people want to be respected for their contribution, so that's why I want to find the right person. But anyway, and which is why I'm gonna change Snell's law to something else because Snell's didn't create that one. Um, we'll figure that out later. There's a bunch of people I had to figure out. Anyway, so how do I prove this? So first of all, we're talking about surface integral. Well, the reason this works is because we're bounding it, right? We're bounding it so the curl works and then the surface integral works, and that's the idea that I got from ChatGPT. And they're ridiculous, like how to prove that rigorously. Um, and we get to here, and then now it's just algebra. In all honesty, it is technically like there's a slight proof here to show that this can be interchanged or something like that, but I skipped over it because why the hell would I care about that? And then we just out. It's just moving, like you just treat it like A, B, C, D, the variables you learned, and then you just shift it over to get this part, and you can kind of see that this part is the determinant over here, while this part is the f of x that we claimed. Anyway, where was I? I'm gonna continue on the talk of, yeah, of the intuitive version. I think the intuitive version makes a little bit more sense, where you kind of see how there's like a little change over here, delta change over here, and you can kind of see the transition from H to the VU section over here. Kind of see the transition and how determinate, because it's a parallelogram, would work out to be the same thing. Um, so what does that really mean? I can show you over here, which makes more sense. And now you're gonna see my clunky organized crap here, because it's very unorganized, because the spacing, that's the problem, and this doesn't even have one question, but you can kind of see the original boundary and new boundary. I'm gonna probably hopefully do it with each and every one of them, so I'm gonna do it with this one too. And this one's pretty easy. What will happen is that it'll be 0 pi on this axis over here, and then let me do it with this one. With this one, 0 to 2 pi, and then it'll be infinity that way, and that's it. I could do that. Over here, you see the negative here. That's not a problem, because this thing is a constant, which means that the x and boundary will not affect it, because the Jacobian matrix has to be absolute, from what I remember. So luckily that didn't matter, but it becomes a problem when this the boundary doesn't is not negative, and this number gets inputted here. The integral gets a lot harder when that happens, and it's not fun. Obviously, the spacing issue again, because I destroyed the spacing, because I oh, and this is I can finally change this to 14, because I was meaning to change it to 14 to make it look better. I forgot about that one. Yeah, let me just change that up, because that one should not. Yeah, I forgot that goes off the screen. And then we have the inverse one, which I don't want to prove, but as I did with the Jacobi, I said I wasn't going to prove earlier, and I proved it, because I might go all the way to ChatGPT, ask it a billion questions. But just so you know, that ChatGPT thing, I did it multiple times, like like 5 different sections with 2 different email accounts, to figure that out. It was not fun using that cheap ChatGPT device to figure out the Jacobian matrix rigorous version. It took forever. Now, I don't recommend you do that, but if you want to, you can. It's not that hard. I mean, it's hard. It's gonna be tedious instead. It's just like I have to ask the same question over and over again to ChatGPT until you figure out what's going on. Anyway, that's why I'm gonna do the line integrals either way. These line integrals and surface integrals, I had to do it either way. Yeah, I'm not gonna have fun with that, am I? Oh, by the way, just so you know, this up to here will be all the math I learned from the math department and all the physics department that I learned personally. And then after that will be the chemistry, all of the chemistry I learned from the chemistry. But then it's going to be MAE. There is MAE classes with surprisingly a lot of math, which is going to teach you a lot about Fouriers and series. It's going to do. I'm also going to put things in the math section that I just think they should have added like the hyperbolic functions, and I think I'll also add in a little bit of the Fourier's transform and the Z transform, because we never got taught that. But in reality, I think I should have got taught that in the math department. I just think I just got bad luck on choosing which professors to choose, because I remember by differential equation, class, I chose possibly the well, he even said it himself. He's not really a PhD. He's a master's, and it was like a weird shenanigans. Everyone agreed that was we didn't learn everything because even here, like for stuff like uh I didn't get taught in the class. I learned this from a friend of mine that took a different class, and I learned it from him. So like there's a few things here like this one I never learned in that class. Like there's a few things that I didn't learn from him, but it makes sense. He was a master's student, not a PhD. For some reason, they were low staff on the math department. For some reason, I think they had too many people going for Math 20D for some reason that year, out of no reason. Anyway, with that said, I think I'm done. Because I'm gonna have to. I also want to find a proof of this Lagrangian multiplier in 3D minimax because I found out that you could bang ChatGPT for 3 days or 2 days, and eventually you'll figure it out what I'm looking for. Other than that, I'm gonna have to look at YouTube a lot, which has mixed results. Sometimes I find something, sometimes I don't. And the other thing I'm gonna do is probably look at more textbooks. Honestly, but it's like a pain in the ass to figure out. But I know most of the math stuff. I know how. I mean, you can just follow the math and figure it out. Finally added the gradient thing here too. Um, yeah, I got deleted that old one with the weird thing. I figured out what this was in the thing. This was actually used to get gradients, uh, which I didn't realize until like a few minutes ago. That makes sense. Um, yeah. So if you have something like a speed, you're trying to get the gradient. I don't know how to make a gradient of something with three variables, although that would be a shocking revelation, I guess. Um, anyway, with that I've said, I'm